So the goal here for me was really to talk about the use of artistry and technology and what our restorative futures look like. And I think that's important, those words, restorative future. And the reason I say that is because technology to me is paramount to what we're doing. But I also want to be clear that the artistic side is still a very important part of the process. And I'll set the table kind of early and let you know that for those of you who don't know me, my laboratory is six people. We're a six-person team here. We have in our six-person team three scanners, three milling machines, and a printer. So people tend to kind of think I'm not the digital guy, and I won't profess to be the most talented digital person in the world. I'm definitely not. I'm lucky I have a great team with me, and Jen and Helen and the rest of my team are even better at it than I am. But we do utilize it. What I'm most concerned with is that I'm able to provide more than just that. And what I mean by that is that human element. I want to look at the people, I want to look at the artistry, and I want to infuse the technology with that process. So a little quick about me. This is my laboratory in New York, for those of you who haven't been here before. Richard said I also work with IDT. I'm currently the editor-in-chief of the magazine. Hopefully some of you are reading my editorials every month and some of the other things that I write in there. It's meaningful to me, and it gives me a voice in our profession to be able to work through it. And plus, I always joke I have so much extra time on my hands that it's fun to sit around and go through everything else. This is the main room in my laboratory. You can see upstairs. Actually, you can see a milling machine, my Ceramill up there in the corner. It's actually on the other side of the room now. It's an older picture. But this is where all my digital technology is in my teaching center, which is upstairs on the second floor of my laboratory. And I'm just actually walking in from outside. We just had a group barbecue today, which we try to do every so often here in the lab. And we also utilize the laboratory and the backyard for courses and so forth. So that is us. And our focus is really about one main thing. And the one main thing for me is about people. And I kind of maybe sometimes throw the companies under a bus a little bit, because I think part of the process or probably part of the flaw that we face is we spend a lot of our time talking about products and processes. And of course, those are very important, not only to the companies that research and develop and spend so much time making them, but it's also important that they want you to be aware of these products and processes. And although that's fabulous, as the technician behind the scenes or the communicator with my dentist partners and my laboratory teammates and my patients that I see, I want to really focus more on the people and how we help change their lives. The more we can do that, the more our laboratories benefit from it in the big picture anyway. So what am I always looking to do? I'm looking at the patients, and I'm starting by always looking at the face. What does the face look like? Where does the white stuff belong in the face, and where is the pink in the face? And once I understand those three elements, then I want to know who the person is. And let's be realistic. I'm sure you've all dealt with some patients who are, to say it nicely, somewhat nightmare-ish as a patient to work with. And you've dealt with other patients who are just so happy and so beneficial. I had a patient here this morning who was literally crying and hugging me as she was leaving because of how she felt before she had her work done. And sometimes I have patients here who we've done, an amazing job, I think, sometimes, and everything was beautiful, and they walk out the door angry that there's a little bit of brown stain on the second molar fossa, right? So you have to kind of understand who that person is, and that becomes important in playing in our roles. And why I say it's our role is because I think for us, for our team here that we're talking about as dental technicians, I think I want us all to be viable. To be honest with you, that was one of the reasons I took over as the editor in IDT. I really wanted us to have a thought process of what makes you, the people who are out there listening today, viable 5, 10, 15 years from now. And that number might be scary to people, but it shouldn't be, because even if you plan on retiring in 5, 10 years, you want to retire because you chose to, not because you were forced out. So for me, part of my job or my ability needs to be dentistry. I need to think of dentistry 101, and I need to be able to communicate with my dentist on an educated level with them. I also want to understand the aesthetics. Of course, that's the bottom line, right? Layering ceramics, and I do so much of that still, even though we have so many technological options. And then I want to understand the function. I want to be able to put that all together, and that's where the artistry and the technology really comes from. So is the machinery better today? It's amazing. It blows me away to see what I can do that I couldn't done. And I have to be honest and tell you, I was involved behind the scenes for years with a lot of the machinery before it came out. I remember being in Austria with them on probably 10 years ago when they were developing their first machineries. And I think it's fabulous to see where we've come over this period of time. But in the end, as fabulous as that technology is, it's still in our hands because we're the people who operate that machinery. And if we don't have the knowledge to work through the process, then I think we're missing something, and we become what I call the Me Too people. And the Me Too people are the ones who basically do the same thing everybody else is doing and kind of wonder why you're not getting ahead or you're not being able to be more profitable. So for me, our future is really about a few things. One, I need you to have a clinical sense or a diagnostic opinion. I need you to be able to look at your patients, look at your cases, look at your models, and read them. And I'm going to be cold in saying read them means not making an excuse. Oh, the doctor said A1, what was I supposed to do? Because I hear that so often. You were supposed to know what that means. You were supposed to be able to look at the tooth, look at the cast, understand more information, and break down what you see, an old tooth, a young tooth. I need you to manage your risks. What are the risks? Well, there's several. You have some, meaning that every time you pick up a cast and you're looking to restore, what material option will work best for that case? Because I'm going to argue it's not necessarily the one that the doctor said you should use. And I know what a lot of you think when I say that. Well, that's what the doctor said. But if you're resolved in your belief system, you should know which one is best and be willing to draw those lines when you need to. So that's something that we look at. And by the way, not only do you take on risk, but the doctor and patient takes on risk. Not everybody is restorable. And I think we need to be able to look through the cases and figure out what's the best option functionally and aesthetically for them. So that's an informed consent piece, and you need to be able to communicate with your doctors and your patients about that. And last, and what we'll kind of focus a little bit on today, is really about the material options and how we kind of work through the process of the materials. So for me, when I look at a patient, it's not really about just the patient. Obviously, I'm looking at the face, the white, and the pink. But I said the person, who is he? This guy's name is Adam. And I think you can see right away if you look at Adam's face that even though his teeth don't look like what we would call acceptable, look at the eyes, because the eyes never lied to me. And I spend so much time when I'm talking about photography, how important this aspect becomes for us, especially in a digital world. And when I work through Adam, I don't want Adam to be a bunch of casts, digital or manual, that are sitting in a pan, because that's not enough for me either. What am I really looking for? Something I incorporated about 3 years ago, I think in a Chicago lecture, if I'm not mistaken, was we try to keep a facial picture of the patient on every pan today. And why do we do that? Well, I want to see that patient all the time. I want to pick up that pan and think that's my mother, my brother, my sister. And also, I want every part of my team to feel the same way. I want if the case is in the model and die department and we're trimming a cast, or the case is upstairs and being digitally manipulated, I want to look at that face and make sure that I understand where the white belongs, where the pink belongs, where the horizontal plane is. So that's become pretty much a standard here in my laboratory for a few years now. And then when we start looking in the finer detail, or the micro details, we're starting to look at what we can change. And if you look just up close, if you kind of look at this picture in the upper left-hand corner of your screen, it doesn't really look so bad, does it? It looks like somebody made a bad crown on the 2-1 or the number 9, and it's our job just to restore that. But is it? Because when you go down to the entire face, it doesn't really work. It doesn't really flow in his face, and obviously he's not happy with it. So something as simple as looking at a cast doesn't help you without understanding. I can go into a lot more detail here with this case, but I won't. Just for time with the webinar, I will just kind of quickly point out that obviously he had a ortho-extractance of a lateral at some point, or it was a congenitally missing lateral, and the cuspid was moved into the lateral position, which I would tell you is usually always a nightmare for many reasons, for root form, emergence, and all those critical aspects, and guidance too, obviously. But in the end, it's our job to restore him. And what I try not to do, and what I don't want to say train, because I think that's a bad word, but I guess communicated with my doctors about how I want to work, is most of my doctors today are allowing me to work through the restorative process. Their job, simply put, is to provide space and information. And our job is to fill the space with the proper information. So is this a zirconia case? Is it a lithium disilicate case? Should it be a press? Should it be milled? Should it be layered? All those options have to be thought through. And I have to think through them in many aspects. One, functionally, and two, most important, aesthetically. What are the two that are going to work for me best there? I know we, as a profession, talk so much about strength and hardness. I just wrote an editorial. I don't know if it's going to be in the next issue or maybe 2 or 3 issues from now, but talking about hardness and actually saying that the concept of using megapascal MPa as a measuring stick for materials is really goofy to me, to be honest with you. It's an industry standard, and I get it, but it doesn't make sense because the megapascal test, if you've ever seen one, doesn't really measure strength. It measures hardness and cracking ability. And that's not what teeth are about. Teeth are about flexibility and hardness that are combined together to create strength. So all materials can break if they're hard. And even if they're soft, they can break or wear. So our job is to know what materials work correct for the patient. And in the end, what's really right about that is not about the teeth. Because I know I always show this case and I always laugh because everybody's eyes go to the lower right part of the screen and you look here. My eyes go here. And I look at the face and the human and I think that's what matters in the end. Because I'm sure you and I can all take a retraction photo of those teeth and pick them apart, all the good and all the bad, and did I miss a value here or an angle there, or is there something that I should have did different or better? Probably a million things. But in the end, what matters is the person. And this person is the kind of person that once you've helped them, that doctor receives a lot more referrals and a lot more work, which means we receive a lot more work and referrals, which means the companies benefit from their products and processes. So I think the big picture for me is really about what we can do. And as we do better, it really seems to make the improvement across the board. It's kind of that, what do they call it? The give and, not the give and take, there's a term for that. Pull it forward or push it forward or something. Anyway, technology. So let's talk about technology. Obviously, I'm using technology. I told you how much equipment I have and all the things that I'm doing, but I think technology has a lot more than just a milling machine. Technology to me has so many things that are technological for me. An example might be a shade taking device or a camera. I'm a 6-person laboratory. I own 6 cameras here in my lab, and I'm looking at 2 new ones right now. Why? Because it's probably my most important tool across the board. I told you I have three scanners. I have a printer. I have 3 milling machines. And each one of them are really valuable to me. But in the end, what matters most? My vision of how I use each one of those. And as we see, when I say the words product and process, I think you'll notice that probably the biggest influx we've had in our profession in the last 2 years is translucency. And translucency is fabulous because it really allows us to do a lot of things. But it's not always our best friend either. So although I use a lot of translucent materials, I really like them the most in the monolithic posterior range. In the anterior, I have to be really careful about when, where, and how much translucency I'm using. So if you look at the number 8 tooth here or the 1-1, and I'm going to make a zirconia core on that. I did this case a long time ago, and I think this was the one of the first or second generations of the ZIRCONIA. And what was interesting is, at that point, we did have a more translucent material, so I made 3 different copings. One of them was a colored coping, where I actually colorized it. And back then, I'd be honest, the colors were really not that good. Today, they're much, much better. And by the way, I know you're listening, Richard. The pink, I think, in the AG system has finally really gotten nice. I'm actually using that in one of the courses here next week. Then I used a more opacified material and a more translucent material. And I think if we kind of look at the patient, we start to say, well, which one of those materials is the right one to meet the needs for this patient? And if I put them all on the cast, you can start to see the difference a little bit. Obviously, the colored one looks a little colored, and the brighter and the translucent, you kind of see the differential between them all. But where it really matters is what's behind that tooth. So if I blacken the prep shade with a black magic marker, like if there was metal or coloration on the tooth, and I put on 2 of the copings, what do you notice right away? Even the opacified coping, I'm still seeing the black and the gray kind of come through. So that means I'm dealing with a lower value situation right off the bat. And I'm going to have to really figure out, do I thicken up my material, my coping, or do I really start to use more opacities if I'm going to layer or even micro layer? And yet, if I went translucent, look at how much of that coloration comes through. So probably not the best choice for me. And what I did as an experiment years ago was I actually layered all 3 of them exactly the same, tried all 3 of them in the mouth, and I will tell you the one that went in at the end was the most opacified. And I would argue, looking back on this 5 years later or whatever it was, that I still didn't have enough value. I still needed to push the value up a little tiny bit. So really managing your space and understanding how to create value is a critical aspect for me when I'm restoring cases. Again, the technology is there. Part of my job is to understand which parts of the technology, besides for the technology itself, the actual products that are going to be best for me for that particular human or that particular patient. Obviously, with monolithic, the more translucent sometimes the better, but again, not always. More translucency based on thickness or space changes the game for us a little bit. What I always want to kind of make sure that I'm understanding is exactly what is my best option. I wouldn't say aesthetics are best in monolithic, but they've definitely gotten a lot better, and I think that's a fabulous process, especially for brachial facial type patients, maybe first, second molars that aren't really in an aesthetic zone. And even ones that are, I think we're getting to the point with some colors and characterizations and improvements that are really getting there. For me, I still think a layered part is what separates my laboratory. And although I have all the equipment that I kind of just boasted about, I will tell you that we're still layering probably 80 to 90% of our restorations. So we're not the hugest monolithic lab. I don't frown on the labs that are more monolithic. I just want to separate myself, and I want you to separate yourself. Because like I always tell everybody, if there's a McDonald's on every corner, and I don't mean to be saying you're McDonald's, but if there's a McDonald's on every corner, how do you differentiate your burger from everybody else's burger? There's got to be something in there. Is it your occlusal knowledge? Is it your communication? Is it your choice of materials? And for us, I hope it's all of the above. We're trying to fit those in. Obviously, with bridges and spans, zirconia is one of the better materials for that. Although, again, limitations. Embrasure spaces, 4mm square type connectors, and obviously the more translucent we go, the more that we have to deal with that embrasure space and those connector sizes. And I know there are tons of studies. I'm involved with lots of them at a few of the schools talking about the etchability of zirconias. I'm going to be a little hypocritical here and tell you that even though I don't care about strength, meaning that if you tell me something's 8 billion megapascals, it doesn't impress me. I do care more about the flexibility and the contrasting colors and strength as far as connector sizes. But when we do finally start to make zirconia bondable by etching, the etching process requires a lot more than a normal etch. And whatever strength you are working with, and again, I would relate those strengths into hardness more than I would relate them into true strength. The more the hardness is, the less you have during an etch process. So the newer studies that I've seen are showing me that if I took a very translucent zirconia at about a 600 megapascal and I etch it for the 20 to 30 minutes that I need to actually start to create a surface, when I'm done, that megapascal strength drops to about 300. And 300 isn't a horrible strength, although it is a horrible strength if you have a very rigid material. So from that point of view, I get a little kind of concerned about how we're managing that. And I always tell everybody that even though I don't think we're 100% bondable yet, if you are cementing, I'm a big fan of Z-Prime. Z-Prime is a Bisco product. I know your doctors call you quite often to ask you what material they should cement with, whether it's a Panavia or a GC product or we like Unisem a lot. So there's a lot of different cements out there. Part of your job to be knowledgeable, because that's where your viability comes in the future. So we look at all those options, and my slide's not changing. And in the end, we're going to start with design. Design is really important to us, and I want to be clear. Obviously, we could do a lot of this design in the digital world, and I'm really fine with that. We're doing more and more. But when it comes to true waxing, I have to be honest and tell you that for me, we're still in the hand mode of it. And we're in the hand mode for many reasons. I feel like we can get the most detail, the most contour. And at this moment, it's just easier for us. Now, Jen, who is partner with me, might kind of say a little bit differently, that she's a little bit more comfortable sometimes. And as she says that, I can tell you she's sitting on her bench right now waxing up a case. So we like the ability to still do things by hand. And actually, the case she's waxing now is the upcoming course that we have. And this was actually the similar one that we had done in the course I did in London. So you see the diagnostic approach of my buildup of wax, and then you see the cutback. And what was interesting about this case was I cut it back in two different ways on purpose. The laterals are going to be micro-layered. And I want to micro-layer them because I do a lot of that today, and I think our profession is doing a lot of that. So the micro-layer for me means I only have 0.3 to maybe 0.5 or 6 tenths to work in if I'm lucky. And my centrals are going to be fully layered, which means I have 1.2 to 1.5 millimeters to work in. And now my task is, how do I manage that space? How do I make the centrals look like the laterals? How do I manage the values of all these things? So we go through that in a lot of the hands-on components. Shameless plug, I guess. We have one here in October. I think it's just about sold out, though. I don't know, it might be 1 or 2 seats. But in the end, this is what we're going to kind of try to address, right? The goal here is always to talk about how do we manage space and color. And then the other part of that is, now that we understand what our frame should look like, how do we mill it that way? Because I'm going to tell you that 2 years ago, I probably couldn't have. My milling machine would maybe double scan and copy what I put in there, but it would never really reproduce exactly what I have. Today, I have a better luxury. And I'm going to say that's really because of that third dimension in the CAD/CAM processes and the strategies that have evolved over the years. I think Amon explains it best when they talk about milling and grinding or carving, and that actually that carving is that kind of third ability, that third type of angulation that allows that slight bit more detail. And I'll be honest to say, of course, those milling strategies take us a little longer, not only to compute a little bit through the process, but also in the physical milling time. But I'm okay with that, because if the machine takes 5 minutes more, or 10 minutes more, or 20 minutes more, and I'm getting something out that really has all my little detail in, then I'm really happy about that. So I could do that today very easily, and then it's really about layering and colorizing and how I'm going to manage my space differently. And again, you'll notice here that in this particular space, I'm going to go with a lot more chroma and a lot more bluish grays on the laterals. Why? Because I don't have the same amount of space to work in, and I have a frame, even though it's translucent, I still need the ability to mimic nature and mimic light transmission. Where on my centrals, I have plenty of space. I have my 1.2, I have my 1.5, and all I'm really looking to do is reflect and absorb light in the areas and manipulate my light throughout the process. So we'll build up our ceramics, and actually, usually in courses, this course was, I think, in London a year or two ago, we actually always take one of the participants in the course, use them as the patient. So in this case, I took a picture of a young technician in London. Her name was Rachel, a nice, great girl. And we actually used her as the example of how to follow her natural teeth. So we did all this in predominantly one bake, mostly because I ramble on and babble too much. And we run out of building time a lot in these 2-day courses. But we wound up doing our build-up, our mamelons, our colorations, and trying to put everything in. I added some paint to it, and that was our first fire. And you can see we're fairly close to Rachel's teeth. I think they're not perfect, but for a one bake, we're there. I did a little cleanup and a glaze and finish just because that was all the time that we really had left. And in the end, I think we're accomplishing so much in such small amounts of porcelain. And I think I owe a lot of that to not only the technology and the machinery, but the ability of it of the ZIRCONIA to actually help me in the process, reflecting and absorbing light. And this is where I think the technology has really started to skyrocket from me. So if I look at another patient, this patient happens to actually be a friend of mine and a dental technician. I don't want to show her face because she's asked me not to, but you can see that she was very unhappy with her smile and the coloration of the teeth. And why I'm actually even showing this case is it was an interesting case to work on another technician who is a very talented ceramist. And I kept saying, why aren't you doing this? Why do you want me to do it? And then 8 months later, I think she finally was able to put the case in because you know how that works when you're working on your friends. But why is it interesting? Because in the end, we spend a lot of our time trying to mimic nature. All the little details that we could find, creating chroma and aspects, trying to get the emergence profiles, shape and form, and surface topography, and all the detail. But I have to be really honest with you and tell you, all that means nothing until we can see what that looks like in the mouth. And that's where it really matters the most, is being able to put these cases in the mouth and see it not only harmonize with the surrounding tissue and structures, but then also how it affects the face. And in the end, why I think this case is kind of interesting is because I used a lot of different materials to achieve this. It wasn't one standard material. So in the end, you see the smiles. We did a full mouth rehab on her, and I want you to know I used a bunch of different. I used metal ceramic, layered ceramic margins. I used zirconia layered ceramic. So zirconia copings with ceramic margins also, and fully layered. I used zirconia micro-layered. Several of the teeth were lingual zirconias or half occlusal zirconias with just some micro-layering on it, and some of them were monolithic zirconias. Besides for that, 6 of them were veneers. So I've taken a picture of these under polarized because I wanted you to kind of see the light transmission of all of them. And the goal here is to make them all look the same. No matter if it's metal, zirconia, ceramic, layered ceramic, partially layered ceramic, that is our job, to make them all kind of blend and harmonize the right way. And some people ask me, why did you use so many different materials? And the answer is because I can, and I should be able to. There's a reason why I might want a metal ceramic restoration, flexibility in the posterior. There's a reason I might want zirconia, either monolithic or partially layered or fully layered. And that could have to do with light transition or masking or bridges. And there's a reason I'm going to want veneers or very micro-layered restorations. And why? Saving tooth structure. That's really our job, is to save the tooth structure, not to just prep the teeth away. So I think it's important that we have the support in these systems to do all of these things. And in the milling world, that's where I live. We're kind of living more and more in the Amon system these days. I've had the luxury of working with other systems, but to be honest with you, at this point in my laboratory, we've really stayed in that family for many reasons. And I think not only is the support of the company that I'm happy with, but also the process. When I mill in other systems, I struggle more. And that might just be my comfort level. I'm not saying one's better than the other. I'm saying that for me, that's where we kind of live. But I feel the same way when it comes to even newer technology. So printing is kind of the forefront of our profession today. Everywhere we go, we're talking about printing. I'm actually hosting a show next week in Atlanta at the IDDS, the International Digital Denture Symposium. And this is my 3rd year there, and it's amazing to hear all the growth and the evolution of the printing process. For me, I simplify it. What do I want in my printing process, and how can I be supported by it? Well, let's be clear. There's a million things that we can do today in printing, and all the items that you're looking at here on the screen have all been printed in amazing detail. And I think it's pretty incredible what we can do and how we do it. I think what's common for us is obviously printing casts. And I would argue that it's important. It's not my most favorite or most important thing for me in the laboratory as just printing casts anymore. I know a lot of labs. I was just with a lab friend of mine in Utah last week, and she's doing a ton of surgical guides, and I love it. I mean, it's a way to really utilize our machinery and keep it flowing with different processes, so it's not only about one return on your investment. But like I said to you, in the end, we're still kind of hand wax guys, right? We still kind of want to do a lot more by hand. So part of the challenge for us was, how do we incorporate both? So I'll give you an example of a situation. I don't really have a final on this yet because we haven't finished it, but doctor sends me a scan of this patient to talks about the fact that she has two deciduous teeth in the cuspid positions. They cannot be removed. They want to be restored. Now, I could digitally go in there and actually create files and do everything I need to do and make a printed cast or work in digital space. What I can't do well, and I know my machinery does it, so Rich is probably shaking his head right now that I can mount this on an Artex and move in there and go in there functionally 100%, I can. At the same time, I could have two casts in my hand and really work through, because as great as an articulator is, nothing works as well as the mouth. And I can see a lot more of the movements by hand with two casts on full arches sometimes than I can with almost any articulator in the world. Doesn't mean I'm not an articulator fan. I live by articulators. But I also live by the reference that the articulator is not as good as the mouth. That is the ultimate in articulators. So what would I do with something like this? I could design it digitally, but I have to be honest and tell you, this is a 3-minute, 2-minute wax up. Jen can actually grab some gray wax right on the digital printed cast. And here's the beauty of this. And it was coincidental, by the way, and I'll be showing some of this in the DLOAC, I believe, in Cali next month. It was coincidental that our gray waxes and our white waxes actually almost perfectly mimic the color of our gray printing material and our white printing material. So it was really kind of cool when we saw it. So that's just gray wax added to the cast. That will now go back to the doctor, or I could scan it and send him or her a digital file. And that digital file then becomes for them to utilize and either make a matrix or we'll make a matrix and put that intraoral to test it. And that's where that case is right now. And another scenario similar to that, a full mouth case comes in. It's done through a scan. We take that scan, digitize the casts. We print out our cast in a gray or a white material. We're going to go back and either duplicate that or print out more. In this particular case, the doctor actually did both. He took a digital impression and he took a physical impression. We wound up waxing on the physical impression, which was mounted to a semi-adjustable instrument. And then we took the digital casts and we utilized them as a reference point. So what we actually wound up doing was, after we took our manual digital wax up, we scanned the wax up and turned that into a digital file. So now what I have in space is a digital pre-op and a digital post-op. And I have the ability now to send those back to the patient and the doctor and for them to look at it and evaluate. And I like this aspect. I'm sure most of you are thinking I should do it in white, and I have no problem if you want to do it that way. But most of my doctors are used to seeing the gray because of the detail and textures and so forth. But here's why I like it. When you send a patient their pre-op models, and they're in white or yellow or peach stone, and then you send them a digital model or another stone model with wax on them, they don't really get the concept because the wax doesn't make sense to them. It's our world, it's not theirs. But when I send them two sets of plastic models, one of them is the before and one of them the after, it really makes a lot more sense for them. They kind of understand this is what my teeth look like now, not thinking about material, this is what they can look like after. And this process is kind of a quick and easy scan for us, and then we can just print out the final sets and send those out to the doctor as an orthodontic cast, so we don't have to mount them on a semi-adjustable. They just go out as two orthodontic self-leveling casts. And that's standard for us. And I mentioned support and where I go with support. And I have to be honest with you, I got a little bit lucky here. I was doing a lot of research on printers. I had 2 or 3 in the laboratory. I was testing. And when I finalized, the one that I really felt like was the right direction for us in the laboratory was NextDent. And I will tell you that a lot went into that thought processes, the materials, the options, the support. And then coincidentally, as I was doing that, I discovered that what Aman was doing and actually became one of the exclusive distributors here in the country. So it kind of was a win-win for me. Since I was already in the family, it kind of made it nice for me. I will throw out at you something. I don't know if any of you have seen this, but if you haven't, I'm kind of a big documentary junkie these days. I watch so many of them on planes, and I love the learning aspect of it. That this one's one that I just kind of happened to come across. It's called Print the Legend. It's a Netflix documentary, and what's really cool and kind of interesting about it is you're going to be blown away that the dental profession and every other profession today that's influenced by these micro printers and small printing was the mindscape of a few hippie dudes in Brooklyn, basically, who decided they wanted to kind of get into this business and change how the world saw it. And I won't give away too much of the movie except to say that those same hippie dudes became big corporate people at some point, and it's almost funny to watch how the end of the movie takes a different path. But I'd highly recommend you watch it because it really teaches us a little bit about the process and where it came from. So I've been in the family here for a long time. I could tell you that I started distributing or helping distribute some of the early products with the Smart Box and the articulator and the gear reform, and we still utilize all those aspects. In my laboratory, we still measure and weigh everything through smart boxes. We still use a gear reform for certain cases. Artex is one of my favorite articulators. And then obviously working our way through the Ceramap and across the whole system of milling and scanning is kind of where we are today. I'm not going to bore you with all the aspects of 3D printing. I'm just going to tell you that there's many different versions, whether it's fused or jetting techniques or stereolithography. I mean, all of them have great pros and cons to them. But rather than kind of bore you with them all, what I'm going to kind of jump to the chase here is we're using mostly DLP technology. That's kind of the standard in our profession, although there's a few that are using different versions. But here's what I really care about. This is what you should care about. One, platform size. What's the size of the platform that we can print on? Two, what's the speed? Does it take 16 hours to print something, or 3 or 4 hours to print something, or 30 minutes? And accuracy. You're going to find most of the systems fall within the 30 to 40 micron range, some even a little bit better, some a little bit worse. And some of those just need some fine-tuning based on the type of architecture or the system that you're working your way through. But those are the things I tend to look for. And like I said, we're mostly working in the DLP format, which is a direct light that's being reflected up to the surface. And then you have Rich's video that he actually took while he was here in my laboratory, where it actually shows the platform kind of rising up, and that light from underneath is curing it as it's pulling itself out of the matrix. I love the ability of having different materials, and because I have too much time on my hand, we do a lot of experimenting. So I've had the ability of playing with all the different materials. I've tried a million different frameworks and casted some partials, and I've done some secondary frames over bars that I've printed and then casted. So we've done a lot of fun things. Where I like it the most, and I guess this might lead a little bit into the IDDS for next week, although I'd say in some ways we're in early stages, and in other ways we're completely advanced ahead of our time with it, where I love it is in the denture world for the sense of, one of the things I did a few years back was instead of sending out bite rims, we actually duplicated a denture. We injected white wax into a mold, and we would use the white wax as a reference point instead of a actual pink wax. We'd have white teeth that we could basically put onto the base plate and utilize that. Well, technology jumps fast, and now technology is actually doing that for us. We can actually do a scan of either a denture, or we could pick forms and teeth from a library. We can put them into the white part of understanding where the white belongs in the face, the white and the pink, and now we can actually print these. And this is a really fabulous process because we can actually print this not only from a manual cast, but we could also do it from a digital impression. And that allows us to really get a true idea of where the teeth belong in the patient's face. And now they're adjustable, meaning that we can shorten, add, change, and manipulate to get a much better position right away and not be dealing with the archaic nature of pink wax into the face. The other great advancement, I think, is where we're starting to mill our plates and then have some snap-on teeth or printed or milled teeth. And again, this is just where the technology is going. I think it's really fabulous, and I love the Lego concept of being able to snap things together. I would argue that we're still a little bit on the pricier side to get to where we want to get to, but it is cool, and it is saving us some steps along the way. And when the more we do that, I think the better off we get in the treating of our patient. And I said to you earlier that the model and die wasn't the most important thing to me, but I do utilize it. But where it has become more important to me is we do work a lot off alveolar casts here, and that's where we have a removable either stone die or refractory die that can come in and out and maintain our soft tissue, especially on our veneer cases. And I now have the ability to do that in the printed world, which is really cool, that I can actually print this, and then I could take those dies and either utilize them as a resin material, or I can reduplicate them and turn them into a refractory material and still go back to old school refractory veneers, which, by the way, we still do a lot of here in my office. And it's funny how many phone calls we get from doctors all around the world that say, you still do refractory veneers? That's what we want. That's where the aesthetics are. That's where the best result is. So we still get a lot of that. In the beginning, we tried hard to incorporate the technology into the old school, and that was partly for us and partly for our doctors. I didn't want to just send what they used to receive, stop it, and just send something completely new. So we took our digital casts and we actually mounted them on old school bases with stone and plaster just to make them look a little more normal for the transition. And then as time went on, we started kind of getting away from that. I also love the ability that as I'm designing a cast, I can actually design a restoration, be that monolithic zirconia, which we do, or other materials like lithium silicates, which I'm a big fan of today. And I like the lithium silicates because as I'm making my designs throughout my system, I can imagine the space. I can go back to the face of the patient and look at the colorations, understand which material will work best here for the coloration. Does the patient show that they have a wide smile? Do they see a lot to the back of the mouth, or is there something that you're not seeing as much and we're just really looking for more of the hardness or strength, or is there some functional component? And in our strategy, obviously, we'll lump together all our materials and try to utilize that base as much as we can. We tend to stay on the flatter side, just as a point of reference. I know a lot of people are angling up and changing the angulations, and I think it works well. We're kind of staying a little on the simpler side. I guess as a small laboratory, we can get away with 4 or 5 prints on our table rather than having to try to squeeze a million in there. One of the things we do like, though, recently is we're using a Suprenity material. So as we're designing our cast, we're designing the restoration. That restoration is being machined in my milling system, and the model is being printed at the same time. They take about almost the same time, so I basically get a cast and the restoration at the same time, and then that restoration goes right into a ceramic furnace for about 15 minutes and comes out as lithium silicate. Just a little bit of stain, which I could do either before or after. And I also have the ability to grind, fit, and adjust the restoration because it feels like a resin at this point. And then we can paint our stains and just sinter it in a ceramic furnace, which I really love. Sintering is probably the wrong word. So we do lots of those in lots of situations where we can actually mill and make them both at the same time, and that becomes wonderful. In the end, I started off by really saying that everything really is about the face, the white, and the pink, and that's really where I want you to focus. And for me, that means everything is really about the incisal edge position. Where does that belong in the face? Where does the horizontal plane go? And how do I make that work both in the white and the pink to that patient's face? So if we look at our patient here, her name is Ella. You can see that maybe not the happiest of patients. You can see here in the smile. Look at the eyes, how they tend to kind of close a little bit as she's trying to smile and show some teeth. You can see why. She's had many issues. She's been through a lot. This lady is a wonderful lady. Had a bunch of different ailments and so forth. And in the end, after she got a little healthy and she wanted to kind of get back on her feet, this is the last thing she wanted to address. So we did an old school diagnostic wax up. And that wax up is done to a horizontal reference, either on a Panadent or an Artex articulator, whichever one it is. I'm comfortable with either. And as you know, and as Rich is probably sitting there waiting for me to jump in and say, that can now be transferred into the Ceramill Mind. I can actually utilize that horizontal reference either with an Artex or really almost any instrument at this point, because all I'm really referencing is the horizontal position. Sometimes we'll actually deprogram these patients, right, with our wax ups, but that's not something we need to go into today. And now that I have it in a digital format, I can also design it as a provisional restoration. If I want to make a provisional shell, I have many options here in this provisional shell. I can actually mill it, I can print it, or I can inject it by hand. So I have 3 different versions of how I want to go and get this done. The only one that really matters to me in the end is how do I bring it into oral? How do I get this into the mouth in the right plane? So we do that by actually printing out a version of this and then doing a suck down over the printout. That suck down then allows me to actually take the provisional into the suck down and we transfer it into the mouth that way so we can actually get the horizontal reference. Once we have those positions, we can actually go and put some bisacryl in to evaluate if our position is correct. and then we're going to go fabricate the final restorations. These were all zirconia fully layered restorations with a few monolithic in the posterior second molars. The substructure design is very, very critical, and we spend a lot of time talking about that in both in general and in courses and so forth, because I think designing that substructure becomes critical. And you can see her final result, again, 28 single unit zirconia restorations, all layered with VM9. And there is a nice before and after for our patient. So this is Ella. I want to thank you guys for spending some time with us. I'm just about at our